Somebody's gonna make you wanna turn around and say goodbye. Do that, baby. Are you gonna let him hold you down and make you cry? Don't you know you can change things to blow your way if you hold on for one more day. If you hold on for one more day, things will go your way. Things will go your way. Hold on for one more day. Alright, you guys, I am having too much fun. If you can just hold on for 2 more days till we finish finals, I think you will have a great Christmas break. So, on to Chapter 5 and standard deviation and mean. Let's look at this normal distribution. Record the death rate from heart disease per 100,000 in a group of developed countries. The distribution is roughly described by this normal curve. From this normal curve, we see that the mean heart disease death rate per 100,000 people is about. So what you want to do is find the top of your curve, the very top, and at the bottom, it's going to tell you about what that mean is. It looks like it's going to be here, close to 200, but not quite at 200. So we're going to say 190. Okay. The next question about the same curve is asking for the standard deviation, I think. Yeah, the standard deviation. If you remember from the Chapter 4 review that we just did, the standard deviation is the average distance from the mean. So on page, let me see, I have the book right here. On page 294, you can see at the top, here, I'll put it here, there's a picture, right? And each one of these is a standard deviation. So here's the mean. So here's 1 standard deviation, 2 standard deviations, 3 standard deviations. And it says in the book that you can tell where they start by looking at where the curve starts to change shape and go back this way. And they're all the same size. The book and the test just want you to eyeball this. So you look, and I'm going to say, if this is my mean, then maybe approximately here is a standard deviation. Okay? So from a little bit before 200 to maybe a little bit after 250, the number that's going to best match that is going to be B65. Okay? That distance there. The next question, Scholastic Assessment Test, the SAT scores are normally distributed with mean 500 and standard deviation 100. Jason scores a 440 on the math SAT test. Jason's standard score is. Also, on the bottom of page 294 is this equation for the standard deviation. So what you're looking for is the standard score Z. That's how they compare everybody's score, not by the actual number, but by their standard score. Whoop, hold on. Okay. So Z is equal to his observation, which is his test score, 440, minus the mean, which it gives us, is 500. Okay? And we already know he's going to have a negative score, so he's going to be lower than the mean, because this is going to give us a negative number. Divided by the standard deviation, which is just 100. If you solve for that, you should get, let's see, 440 minus 500 divided by 100. Negative 0.6. Okay, so not too far below the mean, but definitely still below the mean. Right here. Negative 0.6. Do not get confused. I saw some of you getting confused today when we're working in class. Between the negative and the positive, they're going to do this a lot to try to trick you. Okay? Definitely look back and see that he's lower than the mean, so he's going to have a negative score. That's a way that you can check yourself. All right, still on Chapter 5. Scores on the Graduate Record Examination, the GRE, follow a normal distribution. Jennifer's score is 2 standard deviations above the mean. About what percent of scores are higher than Jennifer's? So we need to remember from a curve, a normal curve, one of the cool things about using it is that the area underneath is always equal to 100%. Okay, and we're going to use the 68, 95, 99.7 rule from page 294. I'm going to put it in front of you, which says the scores that are in between -1 standard score and 1, so 1 standard score below the mean and one standard deviation above the mean, all of this light blue color here, that's going to be 68% of the data. It's going to be most of the data is going to fall here. Okay, and then within 2 standard deviations of the mean, so +2 and -2 z-score, that's going to be 95% of the data. And then 3 is going to be 99.7% of the data. So what's the question asking us here? It says about what percent of scores are higher than Jennifer's. So it gave us a really easy problem because if we find, we don't even need to use numbers. If this is 0 and we go 1, 2 standard deviations above the mean, what percent of scores are higher? It just wants this little baby percentage up here. Okay, so if we look here, and we know that all the way from here to here is 95%, and that in the middle is 68%, we'll be able, if you do all the math and subtract the percentages, you should get that this is about 5% here. Here's going to be 5%, and about here is going to be, or 2.5%, I'm sorry, 2.5% here, and 2.5% here, because 2.5 and 2.5 is going to be 5, and if we add that to 95, we get all 100% of the data. So should be 2.5% are higher. Okay? This one doesn't tell you how many standard deviations above it is, but let's draw a quick curve. Whenever it gives you a standard deviation and a mean, if you want to get a look at the data, you're going to draw a quick curve. So, and if I'm talking too fast, you guys, just pause this and you can replay it. I'm trying to talk slower because I do recognize I'm talking too fast. There we go. So this one says the mean is 69 inches for height of adult men, and the standard deviation is 2.5. So 1 standard deviation, I'm just going to add 2.5 to 69, so it's going to be 70, 71.5, and then I'm going to add another 2.5, so 72, 73, 74 is going to be here. So that's 2 standard deviations, that's what we're looking for. What percent of men are taller than 74 inches? That's going to be here again. I don't even need to redo the math because I remember from up here. That's going to be 2.5%. I think it was either Maya or Brittany today. I might have given you the wrong answer on this, so I'm sorry. I hope you watched this. If anybody else watches this and can tell them to make sure that they have the correct answer, that'd be great. So 2.5% of the people are going to be taller than 74 inches. Okay. Scores on the American College Testing College Entrance Exam follow the normal distribution. Most standard tests are going to follow this distribution. It gives us the mean, gives us the standard deviation. His score, his standard score was -0.7. So since it said standard score, I know I'm going to use that formula from the other page for standard score that we just did. But this time, I know z is equal to negative 0.7. Okay, so that means I can put that here, equals, we want to know what his actual score was. That's going to be x minus the mean, which is 18, and the standard deviation, which is 6. And we're going to solve this. So to solve this, we take negative 7 times 6 plus 18. I'm just going to type that into the calculadora. Negative 0.7, I'm sorry, negative 0.7 times 6 plus 18, to get rid of that 18, get x by itself, 13.8. And that's an answer here. Good. I think Wayne maybe needs to take the ACT over again. You guys would know that better than I. All right. That concludes the multiple choice review for Chapter 5. Please read over, and you can do some other practice questions in the book about standard deviation, and especially using those percentage rules. Okay, you are going to really want to make sure you understand where the percents are here and how to get percents over here. If you don't do it, make sure you come see me so that I can do a few with you. All right, have fun doing some more practicing out of the book and studying. This is not the only studying you need to do. You need to do it on your own. And I will look forward to seeing you later.